The following is the video solution from JSDT Solutions. Question 1 says, in the diagram, ADQC and DPB are straight lines. D is a point on the y-axis. A and B are points on the x-axis. The equation of BC is y equals 2x minus 24, and the equation of line AC is 7y minus x is equal to 14. Okay, so this has just not been put in its standard form like the way this one is. And then they tell us that it is given that P is 6 and 1, Q is 7 and 3, T is K and negative 1, and TP is the square root of 293. Okay, so that's the length of that line. And the first question is to calculate the gradient of line PQ. Okay, so we have 2 points on this line. We can find the gradient. Okay, I'm just emphasizing those points. So to find the gradient of a line, the gradient is equal to, and this is the formula. And in place of x1 and x2 with P and Q, you can choose which you would like to be your x1 and x2. So I'm just going to say top minus bottom. So that is y2 minus y1. That's 3 minus 1. So 3 minus 1 all over, and then that's 7 minus 6. So 7 minus 6. Okay, 7 minus 6 is already 1. So 3 minus 1 is 2. So the gradient of line PQ is simply equal to 2. And that is our answer. Moving on to the next question. Question 1.2 says, give a reason why PQ is parallel to BC. Okay, what do we know about parallel lines? If two lines are said to be parallel, okay, if PQ is parallel to BC, then it just means that their gradients are the same because they are sloped or slanted in the same way. Okay, so if we can just show them that the gradient of PQ is actually equal to the gradient of BC, then yes, then they are parallel. Okay, so let's look at BC. We already have PQ, and there we go. The gradient of BC is 2. So we can just show them that BC's equation looks like this. It says y equals 2x minus 24. So we can see now that the gradient of BC is also equal to 2. Therefore, that means that the gradient of PQ is equal to the gradient of BC. And that is our answer. That is the reason why they are parallel. Moving on to the next question. Question 1.3 says, if Q is the midpoint of DC, calculate the coordinates of C. So if Q is the midpoint of DC, meaning that DQ would be equal to QC. So we need to find C. Well, we have the midpoint of DC. We have Q, the midpoint of DC, but we also don't have D. We need D so that we can find C. So how do we find D? Look at where it is situated. It is on the y-axis, meaning it is the y-intercept. So in the equation of a straight line, y equals mx plus c. See the c part? That stands for your y-intercept. We actually have the equation of this line AC. It's this, but it's just not in its standard form. Now, you can't choose to put it in its standard form, or you could just straight away find the y-intercept. And to find the y-intercept, you simply make x equal to 0. So that's what we'll do. Let's take that equation, 7y minus x equals 14. And let's make x equal to 0. So that's 7y minus 0 equals 14. 7y minus 0 is still 7y equals 14. And if you divide both hand sides by 7, y is finally equal to 2. So we can see what D is now. D is a y-intercept 0 and 2. And this will help us a lot. Okay, so now that we know that this is 0 and 2, to find C, we're just going to use the midpoint formula because this is the actual midpoint, and we're going to work through this as if we're trying to find the midpoint, given that we don't know one of the end points. So we can call this x and y since it's unknown currently. Okay, so let's just use these points that we have, D, Q, and C. Okay, so to find this midpoint, we're going to say that the midpoint of DC, right, which we know is Q. Now we find that by saying x1 plus x2 over 2, and then y1 plus y2 over 2. And let's substitute. we are substituting these as x1 and x2 because we're trying to find the midpoint of DC, okay? These are the endpoints D and C. Okay, so we can just put it in the order where the x and the y come first. So we can say that that is going to be x plus the other point, the other x value is 0 plus 0 over 2, and then y plus 2 over 2. Now we're saying that this calculation of the midpoint, right? It should give us, if we knew what x and y were, it should give us this midpoint of Q. So we already have that midpoint. We can say that is 7 and 3. And so these are equal. This is the calculation. This is the actual midpoint. So because they're equal, we can equate their x values and say that this means that x plus 0 over 2 is actually equal to 7, that x value, and y plus 2 over 2 is actually equal to 3. Okay, so let's solve now. X plus 0 is still x. And so we just have a 2. So you can just multiply both hand sides by 2, or you can see this as cross multiplying. 7 times 2 is 14, and x times this invisible 1 here is x. So x is equal to 14. Let's just do the same thing over here. And so we're going to just multiply. So that is y plus 2, okay, when it multiplies to the 1, and then 2 times 3 is 6. So y is just equal to 6 minus 2 when we transpose the 2. So that is 4. Okay, so we know finally that this means that C, that point over there, is simply 14 and 4. And that is our answer. Okay, moving on to the next question. And then question 1.4 says, calculate the size of angle ACB. Let's see what that looks like. So ACB is this angle over here, ACB. How do we find that? Well, do you see that it's created using lines with equations that we have, okay, or at least the gradients. We will specifically use their gradients. So what we can do with this is, let's go ahead and extend these lines. If you extend AC, so we can better understand it, and then we extend BC, then do you see what it creates? There's the angle they're referring to, ACB. Okay, it's this angle because they're vertically opposite. So they're the exact same size. And now to calculate the size of this angle, what we can do is draw an imaginary x-axis. So this is a line that will be parallel to the x-axis, and we're just going to draw it right at that vertex, okay, at that point where C is really created, that angle over there. Okay, and then from this, you can see that in order to find this angle that we're looking for, we simply have to say, find the angle of inclination of this line BC, and if you take that and you subtract it by the angle of inclination of this line AC, then you're going to get this angle ACB. Okay, so it's this entire angle minus this entire angle, and so that leaves you with that red part. Okay, so let's go ahead and find these. So we just need their gradients to find those angle of inclination. Okay, so let's just go ahead and find them first, those angles, using their gradients. So the gradient of BC is 2. We can find that. And let's just quickly find the gradient of AC. So we'll note down that the gradient of BC is equal to 2. And looking at the equation of AC, let's just get that gradient. Okay, so we can just put it in standard form. In its standard form is y equals mx plus c, meaning y needs to just be on its own. Okay, so let's leave it on the left-hand side. So this is going to be, transpose the negative x, it becomes positive, and we have plus 14 still. And if we divide both hand sides by 7, we'll have 1 over 7x, and 14 divided by 7 is 2. Okay, so this is the equation of AC, and that's what it looks like. Since we know that the gradient of AC is 1 over 7. Okay, now we just need to remember what that equation should look like. We are saying the angle of inclination, okay, of BC, since it creates the bigger angle, minus the angle of inclination of AC. And we will find that. Okay, to find the angle of inclination of BC, we'll say tan theta is equal to the gradient of BC, which we can see is 2. And so to find that angle, the angle of inclination of BC, we're going to use the inverse of tan on both hand sides. You can also see this as transposing tan, so it becomes its inverse. So arc tan 2, And on your calculator, you're just going to say shift tan of 2, and it gives that. Now, I don't want to round off yet, just because I would just like to make it as accurate as possible. So I'll leave it as 4349 and just ... so we know we didn't round off yet. And then let's just find the other angle of inclination. So tan theta equals, the gradient of AC is 1/7. So we'll say theta of AC is equal to arc tan of 1/7. And so we're going to finally find that and say this is arc tan 1/7, just to show that we actually are finding these. So this is 8.1301, and we'll just keep going. Okay, and now finally, let's find those angles. So the angle they're referring to, ACB, to find this, we simply say the angle of inclination of BC, 63.4349, it keeps going, minus 8.1301, and let's find that. So on your calculator, you can simply just go to that end and say shift tan and get that angle of inclination. So put 2 there and just say minus that. Okay, and our answer is finally 55 point, and you see that's going to round down. So it's going to be 0.30 degrees, and that is the size of ACB. Moving on to the next question. Question 1.5 says, calculate the area of quadrilateral BODC. Okay, so let's look at that quadrilateral and just see how we can find the area. So, is this quad BODC? As you can see, it's not any recognizable shape. It's not really a trapezium. No, it can't be a trapezium, because if it was a trapezium, you should have 2 sides being parallel. And we don't have that. Okay, it's not parallel to this at all. Okay, because this is a vertical line and this is not. It's a diagonal line. So it's not a trapezium, meaning we would have to divide it. But let's take advantage of the fact that we actually have other shapes here. So let's divide it using the shapes that we already have here. See how we have this triangle, DOB. We could find the area of that triangle and then find the area of this triangle. And that would work out, because you see how they told us to find the angle ACB, right? So we already have this. So to find the area of this triangle, we can simply just use the area rule. Okay, we have an angle. We would be able to find this side since we know what C is now, and we would also be able to find this side. And so that would complete it. And then to find the area of this part, we can see that DO is perpendicular to OB. And so we just need to find B. So we can see the height clearly is 2, and then just find that base by finding B. Okay, so that's one way. Let's explore other ways that we could have also found this. We could also find the area of the shape using other bigger shapes that we have. So look at what we have here. We just need to find DOBC, right? This shape. We could find the entire area of this bigger triangle, and the reason why is it's an obtuse, well, it looks like it is an obtuse triangle that we have here, and we could just use a half base times height to find this one. Yeah, we have this angle, that is true, but we don't actually have to go through the stress of finding this side and this side, because we can actually find this triangle's height. You see, the highest point that this triangle reaches is C. So we could just find out exactly what that height is if we knew what the y value of C was. And there we go, would know the height. So we could find the area of this bigger triangle. Of course, you'd have to find the base, meaning you need to know what A and B are. And then we could also just say, take that entire area and subtract it by the area of this triangle, ADO. Okay, if we subtract it by that, you see how we'll be left with this part, ODCB. Okay, so that's another way. And now just comparing them, they both have things that we just have to find, but this method of finding the area of this entire triangle seems easier, because all we need for this is we need A, we need B, and then that's about it. Because if you have A and B, you can just find that distance. It's a horizontal distance, so you don't even need the distance formula. Okay, so let's go ahead and go with that. Okay, so this is our strategy that we're going to use here. We're finding the area of triangle, and this is triangle, let's call it ABC, triangle ABC. And if you subtract that by the area of triangle, this triangle over here, ADO or AOD, so ADO, then we will find this. Okay, so let's just keep this in mind, and now that's what we're trying to do. Okay, so we need to find out what B and A are. So they are the x-intercepts of line BC and AC. So let's find A first, the x-intercept. To find the x-intercept, just make y equal to 0. Okay, so this is our equation, and we'll just say 0 minus x, and then is equal to 14. We're just making that equal to 0. And so you see this will be negative x. So if you just divided or multiplied both hand sides by negative 1, therefore x will just be equal to negative 14. So that is A. A is the x-intercept, negative 14 and 0. And then we need to find the other point B. And that one lies on BC. So to find B, we're just saying it's the x-intercept of this line. So because it's the x-intercept, you make y equal to 0. Okay, so we're saying 0 is equal to 2x minus 24. And then if you transpose negative 24, you're going to get positive 24 equals 2x, which is the same thing as 2x equals 24. And if you divide both hand sides by 2, x is finally equal to 12. So it means that B is that x-intercept 12 and 0. And so to find BC, the base of that bigger triangle, ABC, we're just going to add their lengths, okay? So from O to A and then O to B, or we could just say the higher one minus the lower one, and then that would just find the length. Okay, so finding BC, we'll finally tell them that BC is found by saying, we'll say the x value of B, 12, minus the x value of A, which is negative 14. So you see how that becomes 12 plus 14, which is finally equal to 26 units. Okay, so we have BC now, and now we just need its perpendicular height. So the area of ABC. So the base is 26. What is the height? This point C, we already found that point. And C was 14 and 4. So since we know that this is 14 and 4, what that means about that height is if this is a y value of 4, then it means that you just went 4 units down, and that's how high this triangle is. It is 4 units. So that's what we're going to take as the perpendicular height. Okay, so we know the perpendicular height of triangle ABC, that is 4 units. Okay, we have everything for triangle ABC. Let's look at triangle ADO now. So with ADO, we actually have the height in this case, because you see that DO is perpendicular to AO because they're on the x and y axis. So that is the height. The height is 2 for DO. And we already found A. So we know that this from O to A, okay, this is negative 14. So it means that AO is 14 units. Okay, so this way is actually quicker than the other way. So we can find that. Okay, so we know in triangle ADO that the base is equal to 14 units, and the height, the perpendicular height, that is 2 units. Okay, here we already know the base and the height. So let's go. We're saying the area of triangle ABC, let's just put it as a whole. To find the area of this quadrilateral, they're referring to BODC. BODC, we simply just say that this is equal to the area of triangle ABC minus the area of triangle ADO. And we're just going to fill in. So to find the area of triangle ABC, we say a half times that base of BC, which is 26 units, times the perpendicular height, which is 4 units, minus a half times the base of ADO, which was 14 units, and times the perpendicular height, which was 2 units. And this will give us the area of quadrilateral BODC. Okay, so we can say a half times 26, that's 13, 13 times 4 is 52. And then minus a half times 14 is 7. And 7 times 2 is 14. So minus 14 again. Okay, and then 52 minus 14. And that gives us 38. So there we go. That's the area of this shape. BODC, it's 38 units squared. Okay, 38 units squared. And that is our final answer. Moving on to the next question. Question 1.6 says, if TP is equal to the square root of 293, which they told us, determine the value of K. Okay, this is not a problem. And the reason why is because it's just K alone that is missing. And they're telling us that we need to find this if the length of this line is 293. So the length of TP. So we're going to take T and P. And because they're telling us the length, we're going to use the distance formula and substitute these values, okay? We can take that as x1 and that's x2 and y1 and y2. And then we'll just substitute that we know what the length of this line is. Okay, let's go. Okay, so to find the distance formula looks like this. And we're saying TP is equal to, and it's the square root of x2 minus x1. So that's k minus 6. K minus 6. I'll just keep that as x2 because I want the k to be in front. All squared plus, and then y2 minus y1. So you have to be consistent. If you start with this, okay, then with the y's, you need to start with this as well. So that's negative 1 minus 1 all squared. And we know what TP is. It is the square root of 293. So we'll say in place of TP, the square root of 293 is equal to, and let's just see what can be simplified here under this radical. So k minus 6 all squared. Let's distribute that. You can't just write this as k minus 6 times k minus 6 and then FOIL out, but that can take quite long. So what we can just do is square the first term, that gives us k squared, square the last term, that gives us positive 36, and then say first term times second term, that will give us negative 6k, and then you just multiply that by 2. So that's negative 12k. Okay, negative 1 minus 1 is negative 2, and then we have that being squared, so that becomes positive 4. And now at this point, you see that what will be a problem would be these square roots. So we're going to cancel them out by squaring both hand sides of this equation, and we have 293 equals, and those cancel. Now we have k squared minus 12k, and 36 plus 4 is 40. Okay, let's transpose this, 293. So 0 equals k squared minus 12k, and then if you say 40 minus 293, that gives us negative 253. Okay, so this is what we have, and we have to factorize. So 253, not a very nice number to use, but not a problem. We're going to open up two brackets, equate it to 0. And we're saying k multiplied by k gives us k squared. And we need factors of 253, but one needs to be negative, one needs to be positive, and they should give us a 12 in the middle. Now, with this, it ends with 3, so it's an odd number. It may not have a lot of factors. Here's how you can just quickly do this. 253 is equal to, and when you press the equal to button, press shift and fact so you can see its factors. And so you see that that's 11 and 23. So if it's 11 and 23, but they need to give you a negative 12 in the middle, which should be negative so that we can achieve that. You should make this negative, the bigger factor. Okay, so if you say negative 23 plus 11, you do indeed get negative 12. Okay, so we can see that those are factors. So plus 11 minus 23. Okay, so therefore, this means that k is either equal to negative 11 or k is equal to positive 23. And now we can decide based on where k is. You see that k is a point that is in the third quadrant. Okay, and in the third quadrant, we know that the x value is negative. The x values are negative here. So we're going to take the negative value. Okay, we'll just tell them that k is actually equal to negative 11. And that is our answer. Moving on to the next question. Okay, question 1.7 says, E, which is A and B, is a point in the second quadrant such that ABCE is a parallelogram. Determine the values of A and B. Let's look at ABCE that they are referring to. Okay, so they're talking about this shape A, B, C, E. Okay, and E is in the second quadrant. So it forms this parallelogram. I should put it like that. And this over here is E. Okay, and that's A and B. So how would we find this given that this shape is a parallelogram? Okay, here's what we can do. Yes, we know that with a parallelogram, the opposite sides are parallel, but that's not really going to help us very well here since we have 2 points missing. So one of the easiest way to deal with this type of question is if you know that this shape is a parallelogram, then you can use this property about parallelograms. You see, with a parallelogram, the diagonals will always bisect each other. And what that means is if this line AC is bisecting this diagonal BE or EB, then it means that the midpoint of AC is exactly the same as the midpoint of BE. So they share a midpoint. So here's how we can find that. We can just go ahead and find that common midpoint. Now, I can't really say it's at D. I don't know where it is. But we're just going to find that midpoint of AC first and then use that midpoint to find E. Just like we did with that first question over here. Okay, we had this point and then we use that midpoint to find that point C. Okay, so let's go ahead and do this. Okay, so all we just need is that point A, which is negative 14 and 0. C is 14 and 4. B, we already found B. B was 12 and 0. Okay, and then E is missing. Okay, so it's going to just look like this. So the midpoint of AC, we'll find that by saying x1 plus x2. So we can just say negative 14 plus 14 over 2. And then y1 plus y2, 0 plus 4 over 2. And so that midpoint of AC is simply just, that's going to be 0 over 2, which is 0. And 4 over 2 is 2. So 0 and 2. Okay, it's that y-intercept. And now because the shape is a parallelogram, then we know that the midpoint of AC is exactly the same as the midpoint of BE. Okay, so we know that 0 and 2 is exactly the same as, and we're just going to find the midpoint of BE. So the x value is A, so we're saying A plus this x value of 12, x1 plus x2 over 2, and then B plus 0 over 2. So this means that we're saying 0 and 2, okay, they're exactly the same, and that's A plus 12 over 2, and that's just B over 2. So we don't really have to write this. We can just start finding it at this point. So we're saying 0 is equal to A plus 12 over 2, and this simplifies to B over 2. So that's just 2 equals B over 2. Okay. Now you see if we cross multiply here, this is a 0, like 0 over 1, right? So if we cross multiply, this stays A plus 12. And then 0 times 2 is still 0. So if you transpose the 12, A is equal to negative 12. And here, just multiply both hand sides by 2 to get rid of this. So times 2 times 2, that's just 4. So B is equal to 4. And those are the values of A and B. A is negative 12, while B is 4. And those are our answers. Moving on to the last question for question 1.8. Okay, question 1.8 says, determine the equation of the line which is perpendicular to AC and then passes through this point. Okay, so to find the equation of this line, we simply need a gradient and then the value of C. We can find the value of C by using this point that we have, Q, 7 and 3. And to find the gradient, they told us that it is perpendicular to AC. So what was the gradient of AC that we had? AC is this line, and here is the equation. We got the gradient at some points when expanding it so that we could just find that y-intercept. Let me just see where that was. Okay, so yeah, we already found that gradient. Okay, so it is 1 over 7. So if that's 1 over 7, then the line perpendicular to AC, the gradient would be, the gradient of that line would simply just be, we'll take that gradient of AC, right, 1 over 7, and you just switch the numerator and denominator, making that 7 over 1, which is just 7, and then you multiply this by negative 1. So that's negative 7. And so that will hold the theory that if you have the gradients of perpendicular lines and you multiply them, they will give you -1. Okay, so here's the gradient, and that's a point on the line. So we can either use y equals mx plus c to find this, or y minus y1 equals the gradient, and then times x minus x1. Okay, so y minus, now x1 and y1, that's x1, that's y1, since it lies on this particular line, which is perpendicular to AC, and we're saying y minus 3 equals, and we have -7 times x, and the x value is 7. Okay, so just distribute. So that is -7x. That becomes +49. And then we transpose the negative to become positive. So what is 49 plus 3? And we're going to have 52. So this is simply just y equals, and we'll just put that there, y equals -7x plus 52. And that is the equation of the line perpendicular to AC. And that is it for question 1, which is a total of 25 marks.